In this video, you're going to learn what parameters and variables are, as well as how to create variables and retrieve values from them. By the end of this video, you'll be able to create your own variables to store data under convenient names, and you'll be able to use parameter expansion to retrieve that data and use it as the input to commands. Okay, so let's start off with a few definitions. First of all, what is a parameter? Well, according to section 3.4 of the GNU Bash manual, which I've put a link to in the resources section, a parameter is any entity that stores values. Shell parameters are used to store and reference useful data that we can use in our scripts. There are three different types of shell parameters in Bash. There's variables, positional parameters, and special parameters. We will cover all three of these in the course, but variables are probably the most common type, so we'll be starting with them in this video. In short, variables are parameters whose values you can manually change. If you've not come across the concept of variables before, I want you to think of them like little boxes in your programs. Each box can have a name and can hold a certain value inside it. When you assign a value to a variable, you put data into the box. When you reference a variable, you get the data back out. That's important, so let me say that again. When you assign a value to a variable, you put data into the box, and when you reference a variable, you get the data back out. Okay, so with that in mind, let's take a look at how to create and use variables in our Bash scripts. Let's create a blank script in our Bash course folder called variable practice and add our shebang line. Right, now to create a variable, we need three things: a name for the variable, an equals sign, and the value we want to put inside the variable. Let's say we want to create a variable called student and store the name Sarah in it to use later. To do this, all we have to do is type student equals Sarah. Here we are telling the shell to create a variable called student and to store in it the value of Sarah. It's important to note here that there should be no spaces around the equals sign when you're working with Bash. If you do leave a space, Bash will think that the word student is a command and give you the command not found error. So remember to remove any blank spaces from around the equals sign when you're assigning variables in Bash. Now what we've made here is, in Bash terms, a user-defined variable. It is user-defined because we, the user, have created it and given it its name. User-defined variables sit in contrast to shell variables, which the Bash shell itself creates and gives names to. We'll be covering shell variables in the next video, but for now, just be aware that they exist. In Bash, it is customary to give user-defined variables names in all lowercase. This helps to distinguish them from shell variables, which Bash typically gives all uppercase names, so try to stick to naming your variables in all lowercase wherever possible. Okay, so now we've got some data saved in our student variable, let's see how we can get the data back out again. Let's say that we just want to print Sarah's name to the screen using the echo command. We could type echo, then hello, $, curly bracket, student, then a closing curly bracket. And then when we run this script, we see that we get hello Sarah printed out to the screen. So how does this work? Well, do you remember earlier when I said that when you assign a value to a variable, you put something into the box, and when you reference a variable, you get the data back out? Well, the $curly brace syntax here is used to reference a parameter, which in this case is a user-defined variable called student. The shell will then look for a parameter with the name student and then replace the $curly brace syntax with the variable's full value. This process is called parameter expansion. So, in other words, by typing $curly brace student curly brace, the shell looks for a parameter called student and replaces the $curly brace student curly brace with the parameter's value, which in this case is Sarah. Pretty cool, right? So what's the benefit of this? Why don't we just write Sarah's name in our command? That would be much easier, right? Well, the main benefit of what we've learned so far is when you want to reference a given value in multiple places in your script. By using variables, you can change the value in one place and have the whole operation of the script change. This saves you a lot of typing and can make your scripts less error-prone. For example, imagine that you're creating a script to send emails on behalf of the company to thank a group of employees for their hard work. You can imagine someone writing something like this. Employee equals Sarah, then echo dear $curly brace employee curly brace. Echo, the board and I would like to thank you for the excellent work that you've been doing over the last few months. Then echo, keep up the good work, $curly brace employee curly brace. Echo, best wishes, echo Karen, CEO. Now if we run this script, we get a letter printed out to Sarah. Every place where employee was referenced, the name Sarah was filled in, as we'd expect. Now if we go back in and quickly change the name of the employee to John and rerun it, we get a different letter printed out with all the names changed to John. So just by changing the value we store in the employee variable in one place at the top of our script, we can change the way our script functions in multiple places. This is not only easier, but it's also less error-prone than changing each value yourself manually. Although it might seem basic right now, as we progress throughout the course, variables and parameter expansions are the kinds of things that will allow us to operate on hundreds, if not thousands of files and pieces of data in our scripts with very little effort. But let's not get ahead of ourselves. We'll be covering all of that cool stuff in the later sections of the course, but for now, I just want you to grasp 3 fundamental concepts. Firstly, according to the Bash manual, a parameter is an entity that can store values. There are 3 types of parameters in Bash. There's variables, positional parameters, and special parameters, with variables being the most common type. There are also 2 types of variables, user-defined variables and shell variables. We will cover the other 2 types of parameters, which are positional parameters and special parameters, in a later section of the course. Secondly, you learn that you can create user-defined variables by writing a name in all lowercase, an equals sign, and then the value you want to give the variable. Just make sure that there are no spaces around the equals sign or you'll get a command not found error. Finally, you saw that to get those values back, we simply put the name of the variable we want inside a $curly brace syntax. This will cause the shell to look for a parameter with the name that we give it and replace the $curly brace syntax with the parameter's full value using a process called parameter expansion. As a final side note, if the shell can't find a parameter with the name you give it, maybe because of a typo or because the parameter wasn't created yet, it will simply replace the $curly brace syntax with pure nothingness. This video has focused solely on user-defined variables, which are variables that you name yourself. But Bash makes loads of useful information available in what are known as shell variables, and it would be great for us to know how to take advantage of those. So I'll see you in the next video, where we'll be going over some very useful shell variables that you can use in your scripts. Looking at shell variables, which are also known as environment variables. In the last few videos, we've been focusing on user-defined variables, which are variables that you, as the shell user, define in your scripts. However, there is another type of variable, called shell variables, that have particular meanings to the Bash shell, and that it sometimes even creates for you to make your life easier. In this video, you're going to learn about some commonly used shell variables, what they do, and how to use them for yourself. By the end of this video, you'll be able to explain the difference between Bourne shell variables and Bash shell variables. You'll be able to explain the purpose of the path, home, user, hostname, host type, and PS1 shell variables. And you'll be able to access the data held in these variables for yourself. So let's go ahead and get started. Okay, so let's start off by taking a look at what shell variables are. Chapter 5 of the Bash manual, which I've put a link to in the resources, tells us that there are 2 types of shell variables. There's Bourne shell variables and Bash shell variables. If you remember back to the beginning of the course, where we were talking about the difference between a shell and a script, you learned that there are many different types of shells. There's the Bourne shell, created by Stephen Bourne in 1979. There's the KSH shell, the C shell, and many others. Now the Bash shell is actually based on Stephen Bourne's Bourne shell. This is where Bash gets its name as the Bourne Again shell, or Bash. Unsurprisingly then, some of the shell variables available to Bash are the same as those available in the original Bourne shell. and these variables are called Bourne shell variables. As Bash has become more developed over time, other variables have been introduced that are specific to Bash alone, and these are called Bash shell variables. In essence, however, all shell variables are names recognized by the shell to have particular meanings. Sometimes, Bash will populate these values with useful information so that you have that information on hand. Other times, these variables will have significance to a specific command that will either read data from or save data in one of these specifically named variables. There's quite a lot of them though. There are 10 Bourne shell variables and around 95 Bash variables, so we won't be able to cover them all here. In this video, I kind of want to make you aware that they exist, where to read more about them, and just to show you how to use some of the more common ones. Shell variables aren't really things that you memorize, but rather they're things that you become more familiar with over time as they become more relevant to you and your workflow. If you're curious, you can easily read what they all do by taking a look at Chapter 5 of the Bash manual, which I've put a link to in the resources section of this video. Okay, so let's take a look at a few common shell variables. Firstly, let's start with the path shell variable. That's right, the path variable that we saw earlier is actually a shell variable, a Bourne shell variable to be exact. We've already seen how useful the path variable is and how it stores all the directories that the shell should search for executable files. We can take a look at the value stored in the path variable by typing echo $, curly brace, path, curly brace, or simply echo $path, which is how we saw it earlier on. I want to take the chance here to mention that although in the last video I showed you parameter expansion being done using a $curly brace syntax, which is the more quote official way of doing it, Bash does provide you this handy shortcut of not needing to write the curly braces when you just want to do something simple with parameter expansion, like when you're just referring to a variable's value. Parameter expansion could do a lot more though, as we'll see in the next video on parameter expansion tricks, but for now just bear those two ways of doing parameter expansion in mind, the way with the curly braces and the one without. Because it's easier, we'll stick to using the simple syntax without curly braces going forward whenever I'm just referring to a variable's value. Okay, so let's take a look at another useful shell variable, the home variable. The home variable is used to store the absolute path to the current user's home directory. If I echo $curly brace home curly brace, or simply echo $home, you can see that this has displayed the absolute path to my home directory on the screen, which is /home/z. Okay, now let's take a look at the user variable. There are many instances when we might want to get the username of the current user, like if we were making an interactive script of some kind and we wanted to greet the current user by name, or if we wanted to automatically include the user's username in the name of an auto-generated file. In these instances, we could use the user shell variable. So if we echo hello $user, we see that we get the current username printed to the screen. While the $home and $user variables tell you about the user who was logged in, the $hostname and $hosttype variables tell you about the computer that they're using. For example, the $hostname variable tells you the name that the user has given to their computer, which can be quite useful for setting up local computer networks. So if we do echo $hostname, we get the hostname of the computer printed out, which in my case is IoT Academy. The $hosttype variable tells you what type of processor architecture the current computer is running. Now on Linux, the packages that you download and install tend to be built and optimized for specific processor architectures, so the information held by the host type variable might be very useful information to have if you wanted to write an automated installation script that will download different packages depending on the architecture of the computer the script is running on. If I run here echo $hosttype, we can see that I'm running a computer with an x86-64 architecture, which is the name for the Intel 64-bit family of processors. The final shell variable I want to cover here is the PS1 variable. PS1 stands for prompt string 1, I believe, and it is the PS1 variable that controls the prompt string that you see on each command line in your terminal. If we take a look by echoing $PS1, we can see that we get this absolutely horrendous output in typical Bash-like fashion. Now, most of this is just the color codes that are responsible for adding the color to the prompt, but let's modify it quickly to show you what happens. It is worth noting at this point that although some shell variables come with preset values, you can manually modify any shell variable just like you can with user-defined variables. Okay, let's say that we went super minimalist and we just wanted the dollar symbol to be our prompt before our commands. We could just type ps1 equals, then in double quotes, $, colon, and a space. We're adding a colon and a space here to give us some room on the command line after the prompt. And now, when we press enter, we see that all subsequent command lines have that prompt that we just defined. Isn't that cool? We can always change it back by reloading our .bashrc file using source /.bashrc, and we see that everything is back to normal. Now, some people like to play around with their prompt to customize it and make it colorful and whatnot, which you can do by editing your .bashrc file. I put a link to a great website called easyprompt.net, which gives you an easy interface to generate the code to build a cool prompt, complete with colors and everything. Check it out if you're interested. As a final note, you'll probably have noticed that all the shell variables that we've gone through have uppercase names. In fact, pretty much all shell variables are given names in uppercase to distinguish them from user-defined variables, which, if you remember, you should try to give names in all lowercase where possible. So that's it for our whistle-stop tour of shell variables. Although we've covered a lot in this video, we've only been able to scratch the surface of all the different shell variables available. If you want more information, please refer to the link in the resources section to Chapter 5 of the Bash manual. In this video, we've seen that shell variables are variables that, instead of being created by you, are actually created by the shell. You learned that there are two types of shell variables, bourne shell variables and bash shell variables. Bourne shell variables are variables that Bash has inherited from the original bourne shell, whereas bash shell variables are specific to Bash only. We also took a look at some commonly used shell variables, such as the home, path, user, hostname, host type, and ps1 variables. These have various functions that you will likely need to use here and there in your scripts. And finally, you learned that shell variables are named in all uppercase to distinguish them from user-defined variables, which should be given names in all lowercase. So, now that you know about user-defined variables and shell variables and how to access their values using basic parameter expansion, we're now going to move on to look at some very cool parameter expansion tricks that you can use to give you a lot of abilities when it comes to accessing values that you store in variables and other parameters as well. So for all that good stuff, I'll see you in the next video. And welcome to this video where you're going to learn some cool and highly convenient tricks that you can use to manipulate the values of parameters. By the end of this video, you'll be able to modify the case of your parameters, determine the length of parameters, and slice parameters to only output the specific parts that you want to work with. These are all very useful things to be able to do, so let's go ahead and get started. So first of all, we're going to look at how we can modify whether our parameter's value is represented in uppercase or lowercase. Being able to control whether our text is upper or lowercase can be very useful when we're formatting text for output or for making sure that data is all in a specific format before performing logical comparisons. So let's start off with creating a user-defined variable called name. In this example, I'll be using my name, but I'm going to write it in different cases so that we can see the changes. So I'll use name equals capital Z, lowercase I, capital Y, lowercase a, and capital D. Now, as we know, we can just echo this out to the screen like so. Echo $name. But if you remember, we can also wrap our parameters' names in curly braces when we're doing parameter expansion, like so. Echo $curly brace name curly brace. And this gives us access to Bash's more advanced parameter expansion features. For example, let's say that we wanted to convert the first letter of my name to lowercase. To do this, we can just add a comma after the parameter name, like so. And when we press enter, we can see that this has changed the first letter of the name variable's value to a lowercase. How cool is that? Note that the original value itself hasn't changed, it has just been represented differently. For example, if we remove the comma and print the name again, we can see that the parameter has still kept its original value. This means that we can apply different formatting to our data whenever we want without risking the modification of the underlying data, which will stay preserved. Okay, so instead of focusing just on the first letter, we can also easily change the entire parameter's value to lowercase by adding 2 commas instead of 1, like this. Now when we press enter, we can see that the entire parameter's value is now shown in lowercase. This is a very handy thing to be able to do when trying to compare whether 2 pieces of data are equal to one another, because the shell is typically case sensitive. Okay, now that we've seen lowercase, let's take a look at uppercase. Let's say we wanted to only capitalize the first letter of a piece of text. This is very useful when formatting people's names, for example, because people's names are usually written beginning with an uppercase letter. Our variable already has an uppercase first letter, but if we take a look at my username, using echo $user, we can see that my username is all lowercase, so we'll use that for this example. If we wanted to convert the first letter of a user's username to uppercase, psst, you might have to do this for an upcoming project. Now, instead of adding a comma, we would just add what is known as a caret symbol, like this: echo $, curly brace, user, caret, curly brace. An easy way to remember this is that the caret symbol looks like a little arrow pointing up for uppercase. Now when we run this, we see that we have successfully capitalized the first letter. If you're wondering where to find the caret symbol, on my keyboard I can get it by pressing Shift and the number 6. If you have a different layout, just Google for the caret symbol, spelled C-A-R-E-T, on your keyboard, and you should be able to find it easily. And yep, you guessed it. Just like when we use 2 commas to convert the whole string to lowercase, we can convert the entire string to uppercase by using 2 caret symbols. So if we try this on our username again, like so, when we run it, we see that the whole username has been converted to uppercase. Awesome. Moving on from modifying cases, another cool thing we can do is to check the length of our variables. So while echo $, curly brace, name, curly brace will just print out the value of the variable name, we can use echo $, curly brace, hash, name, curly brace to tell us how many characters the variable's value contains. Notice here that the hash goes at the start of the parameter name, rather than at the end like the commas and the carets did when we were modifying uppercase and lowercase. And when we press enter, you can see that bash has given us 5 as the output, which is the number of letters in my name. Okay, and for my final trick, let's take a look at substring expansion, also known as slicing. Slicing enables us to take just a small section, a slice, if you will, of a parameter's value, rather than all of it. This can be very useful if only a part of a parameter's value is relevant to you at a particular time. So first, let's create a variable called numbers, and give it the value of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the syntax for slicing is $, curly brace, the parameter name, then a colon, then an offset, then a colon, then length, then closing the curly brace. What this means is the shell will expand parameter, but start at character number defined by offset and expand up to a length of length. Let me explain what this means. In Bash and most other programming languages, a piece of text is just a set of characters strung together, which is why pieces of textual data in programming are referred to as strings. Each character or element in the string is given a number, which is called an index. In Bash, like most other languages, these indexes start at 0 and increase by 1 for each element. So, in our case, element 0 of our numbers variable would be 0, element 1 would be 1, and so on. So, for example, if we did echo $, curly brace, numbers, which is our parameter name, then gave it an offset of 0 and a length of 7, we're telling Bash to start at element 0, which is the first element, and keep expanding until the result we get is 7 elements long. So if we press enter, we see that we get back 0, 1, 2, 3, 4, 5, 6, which starts at element 0 and is exactly 7 elements long. For comparison, if we tell Bash to start at element 1 and give us a result that is 5 elements long by typing echo $, curly brace, numbers, 1 and then 5, we get 1, 2, 3, 4, 5. Okay, now as a convenient trick, if we leave out the length, Bash will assume that we want everything from our offset until the very end of the string. So, for example, if we do echo $numbers:3, curly brace, we're asking Bash to start at element 3 and go all the way to the end. So here, when we press enter, we get 3, 4, 5, 6, 7. We didn't have to specify a length, Bash calculated it automatically. Notice, however, that I didn't put a colon after the 3. If we did put the colon, like this, then the shell will think that we put 0 as the length. A length of 0 will just give us an empty string back, so when we run this, you can see that we just get an empty result, so just be aware of that. Sometimes it might be more convenient to count our offset relative to the end of a string, rather than from the beginning. Instead of starting our offset from 0 and counting forwards, we can also count back from the end of a variable, which can be very useful if what you're interested in is usually a certain length from the end of a string. For example, if we want to get all characters that start 3 characters from the end and get a length of 2, we could type the echo command, a $curly brace expansion for the parameter numbers, a colon, then we're going to put a space and our offset of -3. Notice that we need the space here when we have a negative offset, then a colon, and our length of 2. And as we can see, when we run this, this gives us 7 and 8. 7 is the 3rd character from the end, so Bash starts there, and it expands until the total length of the output is 2 characters long. So we get the number 7 and the number 8. Just remember that when we have a negative offset, it's a rule that we have to put a space after the first colon and before the minus sign, otherwise Bash will get a bit confused and not give us the result that we want. Of course, as we've already seen, we can just say that we want to start 3 characters from the end and take a slice from that all the way to the end of the variable. All we have to do is remove the length, like so. There are many more tricks that you can do with shell parameter expansion, so I've put a link in the resources section to section 3.5.3 of the GNU Bash reference manual for you to take a look at if you're interested. And I've also put the ones we have covered in this video on the sections cheat sheet for you to refer to as well. So let's have a recap of what we've covered here. So in this lecture, you learned how to use some of the more advanced shell parameter expansion features to modify the case of your variables. This is very useful when it comes to formatting and when doing logical comparisons. You've also seen how to calculate the number of characters in your variables, which will come in very useful when we later look at working with indexed arrays. You've also seen how to slice out a certain set of characters that may be more relevant to your purposes, which is definitely a useful tool to have in your pocket when you need it. Alright, so up next, we'll have a quiz to help you review what we've covered so far and also help you get a bit more familiar with these advanced expansion tricks. And in the next video, we'll be moving on to a very powerful technique called command substitution, which is going to be a game changer for your ability to write Bash scripts. So good luck with the quiz, and I'll see you in the next video. And welcome to this video where we're going to be looking at a very powerful shell feature called command substitution. Command substitution is probably one of the most useful shell features, and you'll use it time and time again in your scripts. In this video, you're going to learn what command substitution is and how you can use it in your scripts. By the end of this video, you'll be able to use command substitution to save the output of commands in variables, and you'll be able to use command substitution to use the output of one command inside another command. This is all very powerful abilities, so let's go ahead and get started. So first of all, what is command substitution? Well, it's kind of similar to shell parameter expansion. With shell parameter expansion, when we write something like $curly brace name curly brace, the shell will replace the $curly brace name curly brace with the value of the variable that it's referencing. Command substitution is very similar, except instead of typing variable names and getting the value of the variable, we can write out full commands and get the output of the command instead. A cool concept for sure, but let's have an example. The syntax for a command substitution is to write a $, like we did with shell parameter expansion, but instead of using curly braces, we simply wrap the command we want to run in a single set of parentheses, like so. What this will do is cause the shell to run the command and substitute the $parenthesis command parenthesis text with the standard output of the command that we run. As you can see, command substitution is a very similar concept to parameter expansion, and the syntax is rather similar too. Think of it like this. Instead of looking up the value of a parameter, like we do with parameter expansion, we are looking up the value that comes out of a command instead. To see how this works, we're going to use the date command. So let's create a script for doing this called substitution script and add our shebang line at the top. One of the great things about command substitution is that it allows us to save the results of the command to a variable so that we can use it in our scripts later on. As a side note, for the sake of saving you time when we're watching these videos, I won't be entering the professional components or the exit status when writing many of the course example scripts. Professional components, however, are still important when doing complete scripts, so try not to forget about them when you're writing scripts for yourself. Okay, so let's say that we want to save the output of the date command as a variable called time. To do this, we simply need to write time equals and then add our command substitution with $parenthesis date parenthesis. Now, I want the time variable to contain the current time in hours, minutes, and seconds. The date command has really cool formatting options that allows you to control its output, which you can read more about in the date command's manual page if you're interested. For now though, I'm going to use the plus symbol to tell the date command that I'm going to give it some formatting information, and then type %H for the current hour in 24-hour format, a colon, and %m for the current minute, and another colon, and then %S for the current second. As you can see, this is quite a complex command, but we can use command substitution to save the output it gives in a variable with a convenient and simple name. Okay, so that should save the current time in our time variable. Now, I want to print this out to the user as part of a greeting message. So on a new line, let's write echo hello $user. The time right now is $time. Now we can save this and make our script executable with the chmod command by typing chmod 744 substitution script, and then we can run the script. And we see that the script has printed out a message with the current time. Awesome. Now if we open it back up, we can see that the script runs the date command, and then via the power of command substitution, we capture the output of that command and save that value in a variable called time. We then use parameter expansion to get the value of that variable back out as part of our greeting message. Pretty cool stuff, right? By the way, we don't need to save the outputs of our command substitutions in variables. We can actually just use command substitution to run commands inside of other commands. If this sounds complicated, don't worry, you've actually already seen it before. If I close out of this script and reopen the backup script that we created earlier, you'll see that we've used a command substitution for the date command inside the tar command. We use command substitution with the date command to calculate the file name of the backup based on the time that the script was run, which allowed us to create a new backup file every second without overwriting other backups. Awesome, right? So command substitution is a very powerful technique, and you will use it all the time in your bash scripts. I just want to take a moment to congratulate you on just how much you are learning. You've come so far already, and where you're going is going to be even more exciting. So very well done. In this video, you learned that command substitution is a shell feature that allows you to grab the output of a command and do stuff with it. The syntax for command substitution is the $, and then the command you want to run inside parentheses. This looks just like a parameter expansion, except instead of using curly braces, you use parentheses instead. You learned how to use command substitution to save data in user-defined variables, and you learned how to use command substitution inside of other commands, just like we did with the backup script earlier on. Now, to help you get some practice with this very powerful technique, up next we have another project for you. After the project, we're going to be looking at how we can use arithmetic expansion to perform calculations in our scripts. So enjoy the project, and I'll see you in the next video. People, I hope you had lots of fun trying out this project on command substitution. In this video, I'm going to walk you through the model solution step by step, and you can grab a copy of the official solution script from this video's resource section. So let's get started. So for the first step, we can start by opening our backup script for editing using Nano. Now the first task we need to do is to add in 2 lines of code to make the script greet the user using their username and to tell them that we're going to back up their home directory. Now when you start realizing that your script needs to somehow work with the user's username or get their home directory, bells should start ringing in your head to say that you need to use shell variables. So let's follow our intuition and use the user shell variable to create the greeting line. To do this, we can simply type on the first line echo hello $user. However, we're also asked to make the first letter of the username capitalized for formatting purposes. Now, if you remember back to the parameter expansion tricks lecture, we can capitalize the first letter of a variable's value like this. First, we wrap the variable name in curly braces, and then inside the curly brace, right at the end after the parameter name, we put a little caret, like a little up arrow, and that is what capitalizes the first letter of the parameter. As you can see, although Bash provides a shortcut of not needing to use the curly braces to do simple parameter expansion, putting in the curly braces gives us some really cool extra abilities, so do try to keep both parameter expansion syntaxes in mind. Okay, perfect. We can follow a similar procedure to create the second line, which tells the user that we're going to back up their home directory. Here, we will use the $home shell variable and would simply type echo I will now back up your home directory, comma, $home. Okay, so that's it for step 1. Let's now move on to the second step. In this step, we have to create a variable called current_dir and set it equal to the output of the pwd command. To do this, we have to use command substitution. So on a new line, we can type in current_dir equals to define the variable, and then we can use command substitution and put in $pwd parenthesis to make the value the output of the pwd command. Okay, so that's step 2 done. Now let's move on to step 3. For step 3, we need to let the user know that we will save the backup in that directory. This is also rather simple. We just need to use the echo command and parameter expansion again. Here we might type something like echo, you are running this script from current_dir, and echo, therefore I will save the backup in current_dir, or something like that. Here we can see how we defined the current_dir variable once, but used it in 2 places. Okay, so that's step 3 taken care of. Now for step 4, we just need to make a few changes to our tar command. The first change is that we need to remove the verbose option. The reason for this is that we want the user running the command to see the outputs of the echo command. If we leave the verbose option in there, then those outputs that we want to see will disappear up the terminal, they'll be pushed up the terminal because of the long stream of information that the tar command outputs in verbose mode. So to achieve this, we simply remove the -v option from the CVF options here. We now need to replace the directory with our variable so that it creates the backup archive in the user's current directory instead of in the bash course folder. So to do this, we delete the ~bash course and replace it with our variable, which is $current_dir. We can also change the directory that we're backing up. Previously, we had used the tilde for this, but now equipped with our knowledge of shell variables, we can change this to $home. This will do the same thing at the end of the day, but it just gives us a bit more extra practice. Finally, for step 5, we just need to print out a message that says backup completed successfully to give our users some feedback and reassurance. Here, we just type echo backup completed successfully. And that's it. So now we can save our script. The script already had execution permissions from before, so we don't need to add in those permissions again. So we can run our backup script by running backup script again, and now that you see, we get our new output in the terminal. On my computer, it says hello Ziad with a capital letter, and it tells me that it will back up the home directory. It also tells me that I'm running the script from the bash course folder, and therefore it will save the backup file in the bash course directory. All this information is very useful, as now anyone running the script can see exactly what it is doing and also know where it is saving their backup without having to actually open the script and understand the code. We also get a message saying that the backup script has completed successfully, which as a user is a nice bit of reassuring feedback. If I run ls, you can see that this has indeed created the backup in my current directory. This is great because anyone running this script can get a backup of the home directory created right in the current directory where they're working in, and they do not have to have any specific directory on their system in order for this script to work. I'm sure your imaginary colleagues will be very, very happy indeed. As some finishing touches, just remember to update the last modified date in the script, and also update the description so that our users will know that the script backs up to the current working directory rather than the bash course directory. Okay, so I hope you had fun doing this project and now have a good idea of how useful command substitution and environment variables can be in your scripts. You can download the official solution script for this project from the resources section of this video. Now in the next video, we'll be taking your scripts to the next level by learning how we can use arithmetic expansion to allow your scripts to perform calculations. So for all that good stuff, I'll see you in the next video. People, and welcome to this video where we're going to be having a look at arithmetic expansion. Computers are all about numbers, and in this video you're going to learn how to perform calculations within a bash script using arithmetic expansion. And by the end of this video you'll be able to add, subtract, divide and multiply numbers within your scripts. You'll be able to perform exponentiation and modulus operations within your scripts. And you'll be able to explain the impact of the order of precedence of arithmetic operators. So let's go ahead and get started. So what is arithmetic expansion? Well, don't get too worried by the name. As you've probably already noticed by now, all of the shell expansions serve very similar purposes. Parameter expansion, which we write like this, simply replaces the syntax we write with the value held in the parameter. Command substitution, which we write like this, simply replaces the syntax we write with the output of the command. Now arithmetic expansion, which we write like this, simply replaces the syntax we write with the result of a mathematical expression. You can see that the syntaxes are all really similar between the three expansions. All start with a dollar symbol, but parameter expansion follows that dollar sign with one set of curly braces. Command substitution follows it with one set of parentheses, and arithmetic expansion follows it with two sets of parentheses. Okay, so let's see arithmetic expansion in action. Arithmetic expansion allows us to do calculations in our scripts and uses all the basic mathematical symbols that you're used to from maths class. As you'd expect, plus means plus, minus means minus, slash means divide, and the star or asterisk means multiply. These symbols are called mathematical operators, and the numbers they operate on are called their operands. So let's create a script to test some expressions in called arithmetic script and add our shebang line at the top. Okay, so let's say we want to add two numbers, 4 and 2, and then print the result to the screen. We could do this like so. We type echo, then dollar, then a pair of double parentheses, and inside there we'll write 4 plus 2. So what's going to happen here is that the shell is going to calculate the result of 4 plus 2 and replace our expansion with that result, which is 6. So as far as the shell is concerned, it will be as if we just wrote echo 6. The shell will then run that command and print 6 to the screen. So let's see this working. As usual, we're going to give our script execute permissions by typing chmod 744 arithmetic script, and then we're going to run it. And we see that the script has printed out the number 6 as expected. Awesome. Now, arithmetic expansion gets really useful when we start using variables in our calculations. So let's head back into our script and define some variables that will hold some numbers that we can use in our mathematical expressions. We can define x equals 4 and y equals 2. Okay, now let's put these variables into our addition. To do this, we'd simply replace the numbers 4 and 2 with $x and $y. So what happens here is that the shell first does the parameter expansions, so $x becomes 4 and $y becomes 2. The shell then does the arithmetic expansion and calculates the result of 4 plus 2, which is 6. And finally, the shell runs the command echo 6, and 6 is printed out to our terminal. Now if we save it, and we run it, we see that, yep, we get 6 printed out to the screen. Great. Now, arithmetic expansion actually provides us with a very convenient shortcut. When doing arithmetic expansion, instead of putting $x and $y like we normally would have to, we can simply put x and y. If we save that and run it again, you'll see that we get exactly the same result, which might save us some typing. Okay, now let's try out the other operators in our script. Let's also add in, under our addition, another expansion for subtraction, and then another one for division, and another one for multiplication. Okay, now we can save our script and exit, and then run our script. As you can see, our script now prints out 6, which is 4 plus 2, 2, which is 4 minus 2, 2 again, which is 4 divided by 2, and finally we have 8, which is 4 multiplied by 2. Awesome. It's good to see that maths is still working. In arithmetic expansion, you're able to use multiple operators within the same expression. Now, just like in regular maths, arithmetic expansion has an order in which it performs the different operations to make sure it gives the right answer. Let's say we tried to run echo $, double curly braces, 2 plus 3 times 4. Now the result of this is 14 and not 20. As in mathematics, the shell is adhering to the order of precedence where multiplication has a higher precedence than addition and is therefore run first. So the shell first did 3 multiplied by 4, which is 12, and then added the 2 to get 14. If we wanted to get the 2 plus 3 to happen first, we would have to wrap them in parentheses, like this. Because parentheses have the highest precedence, the shell will now calculate 2 plus 3, which is 5, and then times that by 4 to give the final answer of 20. Note that if two operators have the same precedence, then the one that occurs first, when read from left to right, will be performed first. You can refer to the cheat sheet for this section of the course for a breakdown of how arithmetic expansion handles the order of precedence of the various operators. Now, there are a lot of other expressions that you can do with arithmetic expansion, and we're going to just take a look at 2 more here. The star operator performs exponentiation, which is raising a number to the power of another number. So if we now run the command echo $, double parentheses, 4 **2, as you can see, this has given us the output of 16, which is the result of 4 to the power of 2, or 4 times 4. And the final operator we're going to cover here is the modulo operator. The modulo operator will perform a division like usual, but instead of giving the result of the division, it will give the remainder of the division instead. For example, if we run the command echo $, double parentheses, 4 %2, we get 0. This is because there is nothing remaining after dividing 4 by 2, because 2 goes into 4 exactly. Now if we change our numbers and try to find the remainder of 5 divided by 3, you'll see that we get the output of 2. This is correct because 2 is the remainder from dividing 5 by 3. 3 goes into 5 once, with 2 left over. The modulo operator is a cool way to check whether a number is divisible by another number. If one number is divisible by another, then the remainder of the division will be 0. And if they aren't, then the remainder won't be 0. Programmers use tricks like this to tell whether a number is even or odd by checking whether a number is divisible by 2 or not. In fact, being able to do this and build a so-called fizz-buzz program is a common test in programming interviews, so modulo might end up being your friend for landing a programming job. Now at this point, it's important to note that arithmetic expansion cannot manage decimal numbers. It can only take whole numbers as input and give whole numbers as output. So if we try to calculate 2.5 plus 1, you'll see that we actually get an error, with bash saying that it doesn't understand what the dot in 2.5 is. If we try to calculate 5 divided by 2, we get an output of 2, where the answer should be 2.5. Arithmetic expansion can't give us decimal numbers, so it just gives us the whole number part, which is 2. Because of this limitation, we will often need to use the BC or basic calculator command if we want to work with decimal numbers in bash, and so we'll be covering that in the next video. For now though, let's wrap up with a quick review. In this lecture, you learned that arithmetic expansion is a shell feature that allows you to do mathematical calculations with whole numbers in your scripts. You learned that the syntax for arithmetic expansion is $, then some mathematical expression inside a pair of double parentheses. This is similar to command substitution, but instead of substituting the output of a command, it substitutes the solution to a mathematical expression. You learned how to use different operators in your arithmetic expansions to work with numbers in different ways. And you learned that arithmetic expansion uses an order of precedence when handling operators to determine which operators get run first, similar to how symbols in mathematics are handled. Check the section's cheat sheet for more info on this. Now, as discussed at the end of this lecture, arithmetic expansion is unable to handle decimal numbers. So in the next lecture, we're going to be looking at the BC command, and we're going to be using it to handle decimal numbers within our scripts. So for all that mathematical goodness, I'll see you in the next video. You beautiful people, and welcome to this video where we're going to be having a look at the BC command. As I said at the start of the last video, if you're not interested in learning how to perform mathematical operations in your scripts, then you can feel free to skip this video. But if you are interested, then welcome to the right place. As I mentioned at the end of the last video, arithmetic expansion is not able to handle decimal numbers, but don't worry, this is where the BC command comes in. In this video, you're going to learn how to use the BC command to handle decimal numbers in your bash script calculations. By the end of this video, you'll be able to use the BC command to execute mathematical expressions that require decimal values, and you'll be able to set the scale variable within the BC command to determine how many decimal places should be provided in the output. So let's go ahead and get started. So what is the BC command? Well, the BC command stands for Basic Calculator, and the GNU manual defines BC as an arbitrary precision numeric processing language. In simple terms, BC is a programming language in and of itself that can work with numbers to any number of decimal places. The BC command has an interactive interface which you can access by running the command BC. This opens up a calculator, which we can type in basic mathematical expressions which it will process. For example, we can do 2 plus 2, and when we press enter, we get 4. We can do 8 times 6, and we get 48. To exit the calculator, we simply type quit and press enter. Now, although this interface is useful for doing quick calculations when working from your command line, we probably won't use the BC command in this way when writing our scripts. Instead of requiring the user to type in expressions interactively like we've just seen, the BC command also allows us to pipe expressions to it for it to calculate. Let me show you what I mean. If I run echo, then inside double quotes 5 divided by 2, and pipe the result to the BC command, again making sure that we put the actual calculation within double quotes, this will pipe the text 5 divided by 2 to the BC command for it to process. And when we run this, we get back the answer of 2. But hang on a minute, didn't I say that the BC command handles decimal numbers? So shouldn't the answer be 2.5? Well, yes it does, but in order to make it work, we have to give the BC command something called a scale value. The BC command has an internal variable called scale, which can be used to adjust the number of decimal places that appear in the output. For example, if I want the output to have 2 decimal places, I would set a scale value of 2. If I want the output to have 5 decimal places, I would set a scale value of 5, and so on. So let's say we want to calculate 5 divided by 2 and get the result back with 2 decimal places. We can do this by running echo, then in double quotes, scale equals 2, followed by a semicolon and a space, and then 5 divided by 2, and piping that to the BC command. In this command, we have first set the scale variable to 2 decimal places, and then we passed the operation we wanted the BC command to do, which is 5 divided by 2. You'll notice, as I said, that I've put a semicolon between the scale value and the expression that we want to run. That's really quite important, so make sure you don't forget that. Also note that you need to put the scale value first, otherwise it doesn't work. So I couldn't put the expression, then do scale equals 2. It has to be scale equals 2, semicolon, then the expression. When I run this, you can see that I now get the output of 2.50. Now, because I set the scale variable to 2, the BC command only gave me 2 decimal places in the output. If I change this to, say, 10, we can see that we now get 10 decimal places out. So that's it. That's how you can perform decimal calculations in your bash scripts. So now that we've gone through all that stuff, let's just have a quick recap of what we've learned in this video. So in this lecture, you learned that the BC command allows us to perform calculations with decimal numbers in our bash scripts. You learned how to use the echo command to pipe operations to the BC command with the syntax echo, then in double quotes, the expression, followed by pipe and BC. You learned that the BC command has an internal variable called scale that controls the number of decimal places that are included in the output. Finally, you learned that you can set the scale variable by typing scale equals, then the number that you want, followed by a semicolon, before whatever expression you want to send to the BC command. As one final note, the operators when working with the BC command are pretty much the same as those for arithmetic expansion. The only difference is exponentiation. In arithmetic expansion, you would write 4**2 to do 4 to the power of 2. But in the BC command, you would write 4*2. So just bear that in mind. So up next, we'll have a quick quiz to make sure you're comfortable with all the great stuff we've covered on arithmetic expansion and the BC command. And after the quiz, we'll be moving on to discuss tilde expansion, which is a very useful way to make your work with bash more comfortable. So good luck with the quiz, and I'll see you in the next video. Welcome to this video where we're going to be taking a look at tilde expansion. Tilde expansion is something that you've certainly already used before in your bash scripting journey, but it has a lot of useful features that maybe you haven't come across. In this video, you're going to learn what tilde expansion is and how to use it and some of its more advanced features. By the end of this video, you'll be able to use tilde expansion to easily access your home directory and the home directory of other users. And you'll also be able to use tilde expansion to easily switch between your current and previous working directories, which is very handy. So let's go ahead and get started. Tilde expansion gets its name from the fact that it is performed using a special character called the tilde, which looks like this. Tilde expansion allows us to easily refer to the current user's home directory without having to type out the full path. For example, if I run echo tilde, you can see that this has expanded the tilde character to my home directory, which is /home/ziad. I didn't need to type /home/ziad to make that work. Tilde expansion did the hard work for me. This can save us quite a bit of typing when writing scripts, and it will also make our work more convenient, more concise, and less error prone. Now this is the typical way that you'll probably have already used tilde expansion before, but tilde expansion can do quite a bit more. For example, what follows from the tilde character is also evaluated to see whether it is a valid username on your current system. And if it is, then tilde expansion will expand to the home directory of that user. Now for demonstration purposes, I've also set up another user on my system called colleague. And if I run echo tilde colleague without any space or slash or anything, just tilde colleague, then instead of my home directory, we get colleague's home directory given back. Even though you might not have a user called colleague set up, every system has the user called root, which is the account of the system administrator. You can try this tilde expansion out by looking at the root user's home directory by typing in echo tilde root, which will give you back the root user's home directory, which is /root. As we can see, including a username following the tilde character will expand to that user's home directory instead of the current user's home directory. This can be useful when writing a script as a system administrator that needs to modify many people's home directories. Of course, this expansion doesn't work if the user doesn't exist on your system, so if I just do echo tilde abcd, for example, we can see that I just get back the literal text tilde abcd. The tilde expansion didn't work. Now, tilde expansion can do more than just expand to home directories. We can use it to provide convenient shortcuts to directories that we've already visited. Your current directory is always stored internally in Bash within a shell variable called uppercase pwd. The uppercase pwd here stands for print working directory. For example, I'm currently in my home directory, which is /home/ziad. If I echo $pwd, we see that /home/ziad gets printed to the screen, because that's the current directory that I'm in. Okay, now let's say that we change our directory to the /etc directory. If we echo $pwd, you can see that we're now in the /etc directory. However, Bash also keeps track of our previous directory in a shell variable called oldpwd, which is again all in uppercase. So if I echo out $oldpwd, we can see that it has stored my home directory, which is the last directory that we were in. These variables are very handy in circumstances when you want to keep moving back from one folder to another, like your shell might need to when performing an installation script. However, the variables are kind of long to type out. Fortunately, tilde expansion provides us with some useful shortcuts that we can use. We can write tilde plus as a shortcut for referencing the pwd variable, and we can write tilde minus as a shortcut for referencing the old pwd variable. Because old pwd and pwd are automatically updated every time we change a directory, there's a cool trick we can do with tilde expansion if we have a script that requires us to move between two directories repeatedly. We can actually keep using cd tilde minus to switch back and forth between the two directories at will. For example, at the moment I'm currently in the /etc directory. If I do cd tilde minus, we can see that I've switched back to my home directory. If I do cd tilde minus again, then I can seamlessly switch back to the etc directory. I can do this forever and over again, which can be very convenient in scripts where you repeatedly switch back and forth between two directories. So as shown by these examples, tilde expansion within the shell can be a very handy tool to have when writing scripts that need to work across multiple directories. Although I've tried to cover the features you're likely to use most often, there are other useful ways that the tilde expansion can be used, and I encourage you to check them out in the link I provided to the appropriate section of the Bash manual if you're interested. In this video, you learned that, by default, a tilde character on its own will expand to the current user's home directory. As a technicality, a sol tilde is actually expanding to the current value that's stored in the $home shell variable. This will usually, and pretty much always, be the current user's home directory, but if you're interested, you can have some fun changing the $home variable and seeing how that affects tilde expansion. You learn that any text that directly follows the tilde without any space is checked to see if it is a valid username. If it is a valid username and that user is found, then the tilde expansion is converted to the path to that user's home directory. You also learned about the existence of the pwd and old pwd shell variables, and how you can use tilde plus and tilde minus respectively to refer to them, and conveniently switch back and forth between two directories. Okay, so that's it for tilde expansion. In the next video, we'll be taking a look at brace expansion and how you can use brace expansion to do some pretty magical things that would be near impossible to do on a graphical user interface. So for all that good stuff, I'll see you and welcome to this video where we're going to be looking at brace expansion. Brace expansion is a way to generate sequences of text that follow a particular pattern, and it comes in really useful when you want to operate on lots of files or folders that follow a similar naming convention and you don't want to manually type out each of the different values. In this video, you're going to learn about the different ways to use brace expansion in your scripts. And by the end of this video, you'll be able to use brace expansion to generate text that follows particular patterns of your choosing, and no joke, you're going to gain bash superpowers. Now, everyone wants to get bash scripting superpowers, so let's go ahead and get started. Okay, so as its name suggests, brace expansion is performed using curly braces. There are two types of lists that you can expand to within your braces. The first type are called string lists. String lists can contain any set of individual characters or words. String lists are useful for expanding out to months of the year, for example, or expanding out a set of usernames. The second type are called range lists. Now, range lists are useful for rapidly expanding out sequences of characters that follow a particular order, like the letters from A to Z or the numbers from 1 to 100, for example. Now, range lists lose some of their flexibility that string lists have, because string lists can contain any value, but because each value in a range list does not need to be typed manually, range lists make up for this lack of flexibility with their increased ease of use and extensibility. Let's take a look at some examples with the echo command to see how this all works. As I mentioned, when using string lists, the values do not need to have any specific order or any specific type. We can simply type echo, and then inside a pair of curly braces, pretty much anything we want separated by commas. So for example, we could type A, 19, Z, Barry, 42. Now, as you can see, when we run this, the shell has expanded these different words, letters, and numbers. A more useful example would be to expand out to the months of the year, like echo, then in curly braces, Jan, Feb, March, April, May, June. Now, it's important to note that you cannot put any unquoted spaces before or after the commas in your braces when making a string list. If you do, then the spaces stop the shell from interpreting the brace expansion and the whole thing is treated as a normal command line argument. For example, if I run the original command but put a space between May and June, you can see that the shell has not done any expansion and has just passed the entire string to the echo command as a single command line argument. The same happens if we put a space at the beginning. So if I get rid of the space between May and June, but put a space just inside the first curly brace and then run it, we can see that again, the shell has interpreted this just as one solid string rather than as a brace expansion. Although they're very flexible, string lists are often quite tedious to type out. Range lists can make our lives easier when working with continuous sequences of letters or numbers, like the numbers 1 to 1000 or the letters A to Z. To show the difference, let's create another string list to print the numbers 1 to 10. In a string list, we would need to write echo, then in curly braces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this is simple enough, but it took quite a bit of effort to type out. Now, when we use a range list, instead of using commas to separate each value, we can start with the first value, so echo 1, and then just enter ... and the final value, which is 10. Now, like the commas in the string list, there mustn't be a space around the double dots in a range list though, so do bear that in mind, no spaces around the double dots. And we see that this gave us the same output as the previous command, the numbers 1 to 10, but it was a lot easier to type. It's also arguably easier to read. It just says echo 1 to 10 when you read it. We can also do range lists in reverse. So we can echo 10 to 1, and you'll see that we get the numbers from 10 to 1 this time. We can also do exactly the same with letters in the alphabet. So if we run echo A to Z, you can see that we get the letters from A to Z. Range lists really shine when we consider that there is no limit to the size of the ranges that you can expand to. So even if you wanted 1,000 numbers, you can type echo 1.1,000, and as you can see, all the numbers between 1 and 1,000 get printed out with very little effort. Something like this would not be easy to do with string lists. You can even control the step between each value. So for example, we can do echo 1.1,000 again, but this time we're going to add in .3 at the end. You'll notice that now what we get is the numbers from 1 to 1,000 in steps of 3. It's important to point out that range lists can only expand out to characters that follow a straightforward sequence. The numbers 1 to 10 and the letters A to Z obviously follow simple sequences, but if we did, for example, echo 1.q, then that doesn't work, because there's no obvious connection between 1 and q. It also doesn't work with the names of months, unfortunately. So if I did echo Jan.December, although January and December make sense to us as humans, they don't have any special meaning to computers. A computer would be much happier with numbers 1 to 12 to represent the month numbers, for example. Speaking of which, let's explore this as a practical demonstration. Let's say that you wanted to make a digital journal on your computer to keep track of memories of what's going on in your life over time, and you wanted to create a folder for every month of the year to store your entries in. We can use brace expansion with the mkdir or make directory command to achieve this. So let's make a directory called journal using mkdir journal and move inside of it with cd journal. Now we want to use brace expansion to create our folders. Because they're so powerful, it's usually a good idea to test out your brace expansions using the echo command to see what results they give before you commit to using them in a real command. So I'll be doing that here to demonstrate. Now, brace expansion allows you to add fixed pieces of text to the beginning and end of each element of the expansion. So for our folders, we can do something like month, and then add in our brace expansion, which is curly brace 1.12 for the 12 months of the year. The month here will be prefixed to the command, so it would actually expand to month 1, month 2, month 3, all the way up to month 12. It would be nice though if instead of having 1 digit for months 1 to 9 and then 2 digits for months 10 to 12, if we could have the names of our folders have the same length. So instead of having month 1, month 2, month 3, let's say we wanted to have month 01, month 02, month 03, all the way up to month 12. Well, brace expansion has another nice feature where you can add leading zeros to the first element of the expansion to make sure that all the values of the expansion have the same number of digits. We can do this by adding a 0 in front of the 1. Now if we test this out, you'll see that by adding the leading 0, all of our month numbers have the same number of digits. So now that we've done our testing and we're getting the results we want with our echo command, let's run this brace expansion with the mkdir command to make our folders. A quick ls shows us that we now have the folders that we want. Awesome. Okay, now to finish off our journal, let's say we wanted to create 31.txt files within each of these folders to hold each day's entry. Now obviously not every month has 31 days, but for the sake of example, we'll use 31 days for all the folders. Okay, let's build our expansion with the echo command. Now we can refer to all of the folders that we've created at once by putting in month, then in curly braces 01.12, and then a slash, just like we had when creating the folders. Now we want each of the entries to start with the word day, and we want 31 days. So I'll put 01.31 inside curly braces there. Again, we're using the leading 0 technique here to ensure that all our file names have the same length. Now because we want all of these files to be text files, we can simply add .txt at the end of the expansion to ensure that .txt gets fixed to the end of all the file names. And as we can see, when we run our echo command, that will create all of the different files that we want to make as if by magic. I told you you'd get superpowers. Now that we've tested it with echo, we can just use the touch command to create empty files. So if we replace echo with touch and run the command, bash will go ahead and create all of those files. Now if we check the first folder using ls month01, you can see that there are 31 files starting from day01.txt to day31.txt. We can also check another folder, for example ls month09, and you can again see the same files have been created. So with this command, we told the shell to expand firstly into all of the 12 folders, and secondly to expand and create 31 files within each of those folders. Pretty cool, right? So that about does it for this dose of superhero training and for our coverage of brace expansion. In this video, you've learned a lot of different ways that you can use brace expansion, which can be extremely helpful when writing bash scripts. You learned that there are two types of brace expansion. There are string lists, which are created by having a comma between each value, and there are range lists, which are done by having the ... characters between a possible range of numbers or letters. You learned how to control the step size that is used in expanding a range list by using an additional ... followed by the required step size. You learned how to use a leading zero to make sure that all values you expand to have the same number of digits in a range list. And finally, you also learned how to use more than one brace expansion on a single command line, along with prefixes and postfixes. So a massive well done for learning about brace expansion. It's a very, very useful trick to have in your back pocket when you need it. And it's also cool to show to your friends. So up next, we're going to have a quick quiz to make sure you're comfortable with brace expansion, and then it's on to the section summary. That's right, you've almost completed another section of the course. You are doing absolutely great. So good luck with the quiz, and I'll see you in the next video for the section summary. Course all about variables and shell expansions. The tools and techniques that you've learned in this section will come up time and time again when making bash scripts, so a massive congratulations for working through this section and getting to grips with them. You're doing absolutely great. Now in this video, we're going to walk through the cheat sheet for this section and have a quick recap of the points that we've covered, just to make sure that you're comfortable with everything. I've also put a cheat sheet summarizing everything that we've covered in this section of the course in the resources section for this video, which you can download and refer to whenever you need to. So the first thing we learned in this section is that a parameter is simply any entity that stores values. You learned that there are three types of parameters in bash. There's variables, positional parameters, and special parameters. Variables are the most common of the three, so we've focused on them in this section. You learned that a variable is a parameter that you can change the value of, and you learned that there are two types of variables. There's user-defined variables, which are the ones that you name yourself, and the shell variables, which are the ones that have already been pre-named and have special meanings to the shell. You learned how to create your own user-defined variables by writing a name, an equals sign, and then the value that you want to give the variable. Remember that there should be no spaces around the equals sign, and the name for user-defined variables should be in all lowercase. We then moved on to shell variables, where we learned that there are two types of shell variables. There's bourne shell variables and bash shell variables. We looked at some of the more commonly used shell variables, such as home, path, user, hostname, host type, and PS1 shell variables, and you saw what they contain and some examples of how you might use them. I've also put some links here to full lists of both bourne shell variables and bash shell variables in case you're interested and want to check them out. We learned that shell variables are named in all uppercase to distinguish them from user-defined variables, which are written in all lowercase by custom. You also saw how to use something called parameter expansion to get back the values that you store in these variables. You learned that there are two ways to do parameter expansion. There's the simple way, where you just type a $sign followed by the parameter's name. This saves you some typing, but is only really good for retrieving a parameter's value as it is. There's also the more advanced syntax, where you additionally wrap the parameter name inside some curly braces. This syntax does require a tiny bit more typing, but it allows you to do a variety of highly convenient parameter expansion tricks. We then moved on to take a look at some of these tricks, and we saw how to convert various parts of the value to upper or lowercase, how to calculate the length of a value, and how to slice out a certain set of characters. Note that none of these tricks alter the value stored in the parameter. They just change how it is displayed after the expansion, and the original data stays the same. There are more tricks that you can do with parameter expansion, which you can check out with the link here if you're interested. We then looked into command substitution, where we learned how to use the $parenthesis syntax to directly reference the output of a command. We learned how to take the output from command substitution and save it into variables, or even use it inside another command. Command substitution is a really powerful technique in bash scripting, and you used it yourself to create an improved version of the backup script that you started in the first section of the course. It was then straight into arithmetic expansions, where we looked at how to run mathematical expressions using the double parenthesis syntax. We learned about the different operators that can be used, such as the more standard plus, minus, divide, and multiply operators for simple calculations, as well as more advanced modulo and exponentiation operators. We also learned that there is an order of precedence that determines which order operations are carried out in. The table here ranks the operators in order of precedence, with the ones with the highest precedence coming first and being towards the top. Note that when two operators have the same precedence, the one that comes first, when read from left to right, is the one that will be performed first. We also looked at the BC command and how to use the BC command to work with decimal numbers, because arithmetic expansion only works with whole numbers. We learned that we use the echo command to pipe an expression to the BC command, and can use the scale variable to control how many decimal places are outputted by the BC command. We then moved on to tilde expansion and saw some cool shortcuts that we can use to reference people's home folders and also reference the current and previous working directories. And finally, we wrapped up by looking at various ways that we can use brace expansion when generating text that follows a predictable pattern. So as you can see, you've covered a whole lot of stuff in this section, and now, at the end, you should be able to create user-defined variables, store data in them, and retrieve that data using parameter expansion. Should be able to understand the purpose of common shell variables. Should be able to use the advanced parameter expansion syntax to modify the case of parameter values, calculate their length, and grab particular slices of their characters. You should be able to use command substitution to use the output of one command in another command, or to save the result of a command in a variable. You should be able to use arithmetic expansion and the BC command to do calculations within your bash scripts. And finally, use tilde expansion and brace expansion to make your work on the command line more convenient. So once again, a massive congratulations for covering all that much content. What you know already is probably sufficient to create some really useful scripts. Now in the next section of the course, we're going to take your bash skills to the next level by looking at how bash processes command lines. Bash adheres to a certain flow when dealing with commands and scripts, and it's really important to be able to understand this flow to truly understand what is happening with your commands. Understanding how bash is working under the hood will save you a lot of frustration when writing bash scripts, and will really help bash seem like a structured language rather than just a random set of rules. So for all that potentially life-changing stuff, I'll see you in the next video. Hello there, you beautiful people, and welcome to this section of the course where we're going to be taking a deep dive